Researchers in Australia have created a tiny artificial intelligence chip that performs calculations using light instead of electricity, allowing computations to occur at the speed of light. The experimental nanophotonic processor was developed entirely at the University of Sydney's Sydney Nano Hub, where scientists are exploring new approaches to faster and more energy-efficient AI hardware. The team believes this technology could help address the rapidly growing energy demands of artificial intelligence systems by providing a more efficient alternative to traditional computer chips. Computing with photons instead of electricity. Conventional processors rely on electrical signals, moving electrons through microscopic circuits to process information. This process creates heat, which is why modern chips require extensive cooling systems. The newly developed prototype uses photons, particles of light, to carry out computations. Light can move through materials with minimal resistance, meaning it produces far less heat than electrical currents. Inside the chip, specially engineered nanostructures guide light in precise ways. As light travels through these structures, the interactions themselves perform mathematical operations required for AI processing. Each nanostructure is only tens of micrometers in size, roughly the width of a human hair. Together, they form an optical neural network that mimics the behavior of neurons in the human brain, enabling the system to recognize patterns and complete complex calculations. Calculations completed in trillionths of a second. The prototype performs operations on a picosecond timescale, meaning calculations happen in trillionths of a second, the time it takes light to pass through the chip's nanostructures. Because computation occurs as light moves through the device, processing can happen extremely quickly while consuming far less energy than conventional electronics. According to Professor Xiaoke Yi, director of the Photonics Research Group at the university's School of Electrical and Computer Engineering, the research rethinks how photonic technology can be used to build next-generation processors. He explained that artificial intelligence systems are increasingly limited by energy consumption. By enabling neural network calculations using light, the new approach could lead to ultra-fast, compact, and energy-efficient AI accelerators. Research published in Nature Communications. The findings, published in Nature Communications, demonstrate how machine learning models can be directly embedded into nanoscale photonic structures that manipulate light to perform the calculations required for AI. To test the system, researchers trained the chip to classify more than 10,000 biomedical images, including MRI scans of the breast, chest, and abdomen. Both simulations and experimental trials showed strong performance, with the nanophotonic neural network achieving classification accuracy between 90% and 99%. Towards sustainable AI infrastructure, the innovation could play an important role in making future AI infrastructure more sustainable. Today's data centers consume massive amounts of electricity and cooling resources to support AI workloads. By replacing traditional electronic processing with light-based computation, photonic chips may reduce energy consumption while dramatically increasing speed. Photonics, the science of controlling light, already underpins many technologies such as lasers, fiber optic communication networks, and medical imaging systems. However, its use in computing hardware has only recently gained momentum as demand for AI continues to grow. PhD researcher Joel Sved, who contributed to the design and implementation of the chip, said the prototype demonstrates how intelligence can be built directly into nanoscale photonic structures. Following successful testing, the research team is now working on scaling the technology to support larger photonic neural networks, which could eventually power a new generation of faster and more energy-efficient AI systems.